Hello everyone, welcome to my YouTube channel. In previous video we have discussed about the specular reflection and Purkinje image, and in this video we will discuss about the retroillumination. So in retroillumination, object of interest is illuminated from the light reflected by the structures behind it. So we are going to put light behind the structure which are present behind the object. So in this picture you can see this is the observation system and this is the illumination system. So we are going to put the light behind the structure which are present behind this object to be viewed, and the reflected light is going to illuminate this object from the behind, and therefore the object is getting illuminated from behind. This is called the retroillumination. So here you can see this is the cornea, this is the iris, this is the ciliary body, and this is the lens. So we are this is the illumination system and this is the observation system, and we are illuminating the cornea by the structure present behind the cornea, that is the ciliary body, and we are putting light here, and the light is reflecting from here to this, and this abnormality of the cornea is visible. So in we can obtain retroillumination from the iris, that we can put the iris and observe on the cornea, and we can put the light on the lens and then observe the structure present onto the cornea. So based on where you are putting light and how you are putting light, there are different type of illumination or retroillumination. So in this picture you can see that the object of interest is present to the cornea, so the viewing system is directed onto the cornea, whereas the illumination system, as you can see, is putting light directly onto the iris, which is situated exactly behind this opacity of the cornea, and the light will then get reflected back from the iris, and with this reflected light the object on the cornea will get illuminated. So this is known as direct iris retroillumination. So this is the direct retroillumination of iris. So how can we obtain the direct retroillumination? This is the method that I have mentioned. Make a moderately thin slit beam and directing the beam to the iris at 45-degree angle. The plane of focus on cornea. The soft reflected beam from the iris will enhance transparent corneal irregularities that are too subtle to be observed with other lighting situations. Now we will discuss about the indirect illumination of iris. So here you can see this is the picture showing the indirect illumination of the iris. So we are putting the illuminating light directly behind the object of interest. In second picture we can see that object of interest is located over here, and whereas the light is not put directly behind this, that means on the lens, we are putting it here on the iris. So when light is not projected directly behind the object of interest, it is called indirect iris retroillumination. We can get retroillumination from the fundus also. We will project the light onto the retina, and from the reflected light coming back from the retina we can observe the structure which are present out of the lens or on the cornea. So now in first picture the pupil is dilated now, or in a dilated pupil we project light from the eccentric or from the periphery of pupil, and then we observe the reflected light rays coming from the retina. That Then we observe reflected light rays coming from the retina, and we can see entire detail of the lens. So this type of illumination is used to examine lens structure totally. An indirect retroillumination of iris, the observed structure is not directly in path of reflected light. The retroillumination object is observed against a dark non-illuminated background. It gives a better contrast against a dark background. So here in this picture you can see the indirect retroillumination of the iris. So this is the cornea, and this is lens, and this is ciliary body and iris. So we are observing here, and the light is, the illumination system is present here, and we are not putting light directly onto the cornea. We are putting light behind the structure present to the cornea, and we are putting light in the iris, and from the iris the light is reflected into the cornea, and we can see clearly the abnormality of the cornea. So the indirect retroillumination of iris is used to observe vascularization, epithelial edema, microcyst, vacuoles, dystrophies, crystalline lens opacities, etc. Now we will discuss about the iris transillumination defects. Retroillumination through a small pupil and reflect of the retina. The beam aperture should match the pupil size. So we can also get the retro illumination from the retina. So for obtaining the reflex from the retina, we will put the light at the periphery of the pupil, and the size of beam should match to the pupil size, and we will get a red reflex that comes from reflected light from the retina. And the uses of the iris transillumination, that is the degree of iris thinning or pigmentary glaucoma. So it is used to observe the degree of iris thinning and pigmentary glaucoma. Now we will discuss about the another illumination technique, that is the sclerotic scatter. It is an indirect illumination based on the principle of total internal reflection. So now we will discuss about how can we achieve the total internal reflection. So we will decenter the slit beam, direct the broad beam to the temporal sclera. So we will focus the broad beam of light to the temporal sclera at the as near as possible to the limbus, and light normally falling on the limbus reflects internally and exits at opposite limbus, nasal limbus. So when we will put light on the sclera, on the temporal sclera, so it will illuminate the different layers of the cornea, and from the limbus, from the temporal sclera, the illumination will reflect from the different structures of the cornea, and light normally falling on the limbus reflects internally. So the light will reflect internally and exit at opposite limbus, on the nasal limbus. It result in a glowing limbal ring inside the cornea will visible, which is totally darkened, and we will observe the cornea is totally darkened, and we will observe a glowing limbal ring at inside the cornea. The total internal reflection is equal to occurs at the inner corneal boundaries, endothelium to epithelium. So we can use the sclerotic scatter for the observation of different corneal abnormalities by using a sclerotic scatter beam. So this was all about the retroillumination, direct retroillumination, indirect retroillumination, and sclerotic scatter. Thanks for watching my video.